Okay, so in this lecture, we are on 6.7, which is factoring by special products. And this is the last factoring strategy that we will add to our factoring tool belt. So these are a couple of special cases and just kind of shortcuts that you can sort of memorize to factor quickly when you see certain types of problems. So our objectives are to learn how to factor the difference of two squares and factor the sum or difference of two cubes. Homework is problem set 6.7, posted on Math Lab. Video will be linked when it is complete. So part one is factoring the difference of two squares. In this section, we will learn how to factor special types of binomials, beginning with the difference of two squares. So the difference of two squares is defined as a squared minus b squared, and that can be factored into a plus b times a minus b. So, for example, factor the following: x squared minus 9. We want to write it in a way that looks like our difference of two squares formula. And our difference of two squares formula is a squared minus b squared. So if we're thinking about that, and we want to write x squared minus 9 as something squared minus something squared, we can think to ourselves, okay, the square root of 9 is 3. So I can rewrite x squared minus 9 as x squared minus 3 squared. And then I can see a is x, b is 3, and so I know that my binomial will factor to x minus 3 times x plus 3, according to my difference of squares formula. Let's try another one. So we have 16y squared minus 9. 16y squared minus 9. And again, we want this written as a squared minus b squared. So minus 9 is easy because we just discussed that 9 can be written as 3 squared. 16y squared is a little bit tougher though. We know that the square root of 16 is 4. And then if we think about the square root of y squared, we can think to ourselves, okay, what times what is going to equal y squared? Well, y times y is going to equal y squared. So we can rewrite 16y squared as 4y quantity squared, because 4y quantity squared is 4y times 4y, which equals 4 times 4 times y, which is equal to 16y squared. So we can kind of double check our work over there. And now we can see that a is 4y, b is 3. So our answer is going to be 4y plus 3 times 4y minus 3. Bada bing, bada boom. All right, number 3. Kind of the same theme. We have x squared minus 1/4. And again, we want to add something squared minus another thing squared. So we have to figure out what is the square root of 1/4. Well, we can kind of use our background knowledge on this one too, because we know that the square root of 4 is 2. And so if we think about that, then the square root of 1/4 is going to be 1/2, because 1/2 times 1/2 is equal to 1/4. So we can rewrite our problem as x squared minus 1/2 squared. A is x, b is 1/2. So our factored form is going to be x plus 1/2 times x minus 1/2. Note, a binomial such as x squared plus 9 is the sum of two squares, sum, addition, and cannot be factored because in general, the sum of two squares cannot be factored. But that leads us perfectly into part 2, which is factoring the sum or difference of cubes. So although the sum of two squares cannot be factored, the sum of two cubes, as well as the difference of two cubes, can be factored as followed. So the sum and difference of two cubes say that if you have a cubed plus b cubed, that will factor to a plus b times a squared minus ab plus b squared. And if you have a cubed minus b cubed, that will factor to a minus b times a squared plus ab plus b squared. So we have a couple of examples with this one as well. So number 1, we have factor the following. We have x cubed plus 8. And we want to write it in the form of something cubed plus another thing cubed, because that's kind of what our formula tells us. So we can think to ourselves, what is the cube root of 8? The cube root of 8 is 2. So we can rewrite this as x cubed plus 2 cubed. And then we see that a is x and b is 2. And so we know that this is going to factor to a plus b, x plus 2, times a squared, it's going to be x squared, minus a times b is going to be 2x, plus b squared, which is going to be 2 times 2, which is 4. So my final factored form is going to be x plus 2 times x squared minus 2x plus 4. This kind of looks tricky initially, but I think that you're hopefully starting to see it's not as difficult as it seems. And then we have y cubed minus 64 that, again, we want to rewrite as something cubed, which we have, minus something else cubed. The cubed root of 64 is, in fact, 4, because 4 times 4 equals 8 times 4 equals 64. So we can rewrite this as y cubed minus 4 cubed. And then we see a is y, b is 4, and we know this will factor to a minus b, so y minus 4, times a squared, y squared, plus ab, 4y, plus b squared, 4 times 4 is 16. So this will factor to y minus 4 times y squared plus 4y plus 16. So as a whole, not too difficult. These are just methods for when you see obviously very specific types of problems, like something in the form of a cubed plus b cubed, a cubed minus b cubed, or a squared minus b squared. And these are kind of formulas that you can remember so that you can factor those easily. So that is all for today. And next class, we will go over all of the factoring strategies that we know so far, kind of recap all of that, and then move on to applications. And then we are done with chapter 6. So that's all I got for you guys today. Have a lovely afternoon.